Hi there. What we're going to be working on in today's video is angles and degree measure. And very specifically, we're going to be talking about angles in standard position. So when we talk about angles in standard position, we're talking about angles that are on the coordinate plane. And we are talking about an angle whose initial side, we know an angle has two sides and a vertex. So the initial side is on the x-axis. Okay, so it'll be right here. The vertex will always be at the origin. And then we will have a terminal side. And if the angle is going counterclockwise, like this one is, our terminal side is here, and that is a positive degree angle. And if an angle is going clockwise, this will be an angle with a negative degree. So now the direction that the angle goes will indicate whether it's positive or negative. We have some angles that are called quadrantal angles, and those are angles that are multiples of 90 degrees. So if you look at the first one, it's going counterclockwise, so it's a positive 90-degree angle. The second one is negative 180 degrees. Notice that it's going this way, but if we actually went this way, we would have a positive 180-degree angle. The third one is 270 degrees. It's 3 times 90. And the fourth one, if you notice, is going around this way, and that's positive 360-degree angle. Those 90 degrees are going to be good reference points for us. So let's see if we can sketch these angles and figure out approximately where they would land. So give yourself 4 coordinate planes. And for each of these, of course, the initial side is going to start here. Okay, and again, the vertex is at the origin. So 165 degrees, I hope you're thinking, okay, more than 90, really close to 180. So it's 15 degrees shy of 180. So that's going to look something like this. That's what that would look like. So that's a 165-degree angle. Whoops, sorry, this is a mess. Okay, the second one I'm asking you for is negative 70 degrees. Again, our initial side is not negotiable. It will always be here. Negative 70 means we're going clockwise, and I want you to think, well, that's close to 90 degrees. So here would be 90 if we went to here. So negative 70 would land about here. So that's negative 70 degrees. The third angle is 320, so I hope you're thinking, okay, that's almost all the way around the circle. It's 40 degrees shy of full rotation. So think about what a 40-degree angle would look like. And this right here, right in here, is the 40 degrees shy, but this rotation right here is 320 degrees. And the last one I'm asking you for is negative 150. Again, this side is not negotiable. That's our initial side. Negative 150, we're going clockwise, and we're approaching 180, but not quite getting there. So this is negative 150 degrees. Okay, so when we're dealing with our angles on the coordinate plane, our angles in standard position, we're going to need the multiples of 360. So these are definitely numbers you're going to want to memorize. Okay, there's just no two ways about it. You're going to need to know these numbers. So we've got 360, 720, 3 times around a circle would be 1080. 4 times 360, or 4 times around the circle, is 1440. 5 times around the circle is 1800. And 6 times around the circle is 2160 degrees. So definitely numbers you're going to want to memorize. It's going to be helpful for you. Okay, so in these examples, I'm asking you to calculate the degree measure for an angle represented by that many rotations. And also I want you to sketch the angle. So let's go ahead and sketch it first so you can get an idea of what it's going to look like. So the first angle I'm asking you for is an angle who has 5.5 rotations clockwise. So again, here's our initial side, not negotiable. And now we're going to show 5.5 rotations around the circle. So we start here and we go 1, 2 full rotations, 3, 4, 5 and a half. So that terminal side would be over here. And then I'm asking you to figure out how many degrees that would be. So of course we're just going to take 5.5 and we're going to multiply it by 360, but I want you to keep in mind the direction we went was clockwise, so we will actually multiply by negative 360 degrees. You drop that in your calculator, you're going to get negative 1,980 degrees. Okay, so you're spinning around 5.5 times. For the second one, I'm asking you for 3.3 rotations, and I'm asking you to go counterclockwise. Again, initial side, always over here. So 3.3 rotations counterclockwise. We're going 1, 2, 3, and I want you to think 0.3, it's a little bit more than a quarter of the way around, but not quite half, so it would be somewhere around here. And that's where our terminal side would be. Drop that in your calculator, 3.3 times positive 360, because we were going in the positive direction, you would get 1,188 degrees. So we have to think about our angles being more than 360 degrees. Okay. A word we're going to use a lot is coterminal. And coterminal angles are angles whose terminal side are in the same location. So what does that mean? Well, I'm going to give you an example here. We're going to sketch an angle that is 250 degrees. So I want you to think, here's 90, here's 180, here would be 270, so we're going to be just shy of that 270. So looking at that, it's going to be something like this, and that would be a 250 degree angle. So what I want you to think about with coterminal angles is an angle that would land in the same spot. So in other words, it would have the same terminal side. So the first thing I'm thinking of is an angle that looks like this. So if we think about that, 360, take away the 250 degree angles. Let's see how many degrees were left over to complete that circle. It would be 110 degrees in the clockwise direction, so it would be negative 110 degrees. Okay. I'm going to show you another way we could get a coterminal angle with that. I'm going to draw it over here. I'm going to stick with the 250. Okay, so here we go. We've got this 250 degree angle. And another way we could get an angle that's coterminal with 250 is we could add some rotations in there. So we can, let me get a different color so it shows up. Whoop. We can start here like we do with all angles, and we could go a full rotation and then to 250 degrees. So how many degrees would that be? Well, we did a full rotation and then we did 250 degrees. So a 610 degree angle is also coterminal with a 250 degree angle. In other words, the terminal sides land in the same spot. Okay, so we could have added 2 rotations and then 250 degrees, and that also would have been coterminal. So here's what I want you to do. I want you to give yourselves another coordinate plane here, and I want you to kind of think about what we just did. But I'm going to give you an initial angle of negative 200 degrees. And I want you to come up with 2 angles that are coterminal to that. So you're going to start here, of course. Think about where negative 200 degrees would be. More than 180, Okay, a little bit past that and in the negative direction. So we're going clockwise. Here's 90, here's 180. A little bit past that would be negative 200. Okay, so let's do the same thing here because I want you to show two different examples. So here's negative 200. So what would that look like? So to mimic what I did right here, okay, we can have this angle. Well, how many degrees would be left? So if we took 360 and took away the 200 degrees, we would be left with a 160-degree angle in the positive direction. If we mimic what we did up here, we can go either way. We can go this way, positive 360, and then land there. So now we kind of have to think about, okay, we know this is a 160-degree angle, plus we did a full rotation. So 360 plus 160 is a 520-degree angle. We could have also gone in the negative direction. So there's a lot of different ways we can do this. But if we had done, I'm going to erase that red just to get it out of there for a second. Let's erase that. If we had gone in the negative direction, we could have had negative 360 plus negative 200 and landed in the same spot. So negative 200 and negative 360, we would have negative 560 degrees. Okay, so all those angles land in the same spot. They have when I say land in the same spot, the terminal side lands in the same spot. And so all of those angles would be coterminal. Negative 560, positive 520, 160, negative 200. Okay, so lots of angles whose terminal sides land in the same location. So with that in mind, I'm asking you here to identify angles, all angles that are coterminal with a 225-degree angle. So when we think of 225, okay, of course, we're going to say, okay, that's 0, we start here, 90, 180, 225, we're looking at an angle that's right here. So to identify all angles that are coterminal with 225, we're going to say 225 plus or minus 360K. And what the K represents is an integer. So 360 times 1 or times 2 or times 3 or times -1 or -10 or 1,000, whatever the number is for K, it's not a fraction. In other words, it's an integer. So for a positive example, I'm asking you for some examples. For a positive example, I would just think 225 plus 360, or 225 plus 720, or 225 plus 1080. All those numbers we dealt with before. The simplest one is just to add 360, and we get 585. But there are other answers, because if you added multiples of that, you'd be coming up with other angles that are coterminal. And then another specific example, a negative example, I'm just going to say 225 minus 360. And what that gives us is negative 135 degrees. Again, those are just one example of many, okay, because we have many, many, many examples. So a lot of times we really don't want to deal with like multiples of the circle. We want to take those extra rotations away. So if we look at an angle that's 775 degrees, in the next part of this, I'm asking you to determine a coterminal angle that is between 0 and 360 degrees. Okay, and again, what this does is it takes away those extra rotation and gives us the smallest angle that lands in whose terminal side lands in the same location as a 775 degree angle. So I want you to think about those multiples that we dealt with on the previous page And if we took 360 away, we would still have more than 360 degrees. So the next multiple of 360 was 720. And if we take 720 degrees away from 775, we are left with a 55-degree angle. Okay, and thinking about what that looks like, it would be in the first quadrant. It would be right here. So quadrant 1 is where that terminal side would be. When we have a negative angle like this, and again, I'm asking you to give me an angle that is coterminal with negative 1,297 degrees. What we want to do is, I want you to think about these numbers. So keep in mind negative 1297. I want you to think about these numbers that we have here, and you're going to add the next bigger one. Okay, so if we had added 1080, it wouldn't get us positive. So we're going to go for 4 full rotations. So we're going to add 1,440 degrees, which would leave us with a 143-degree angle. That's an angle between 0 and 360 that is coterminal with negative 1,297 degrees. And where does that land? If you think about it, it would land right there in quadrant 2. So we're definitely going to need some practice with that. Okay. So we're going to talk about reference angles right now. So I want you to really, really, really pay attention to this. Reference angles are the acute angle formed by the terminal side and the given angle and the x-axis. What does that mean? Well, I'm going to show you, and you can refer to this chart. We'll talk about that in a second. So I want you to sketch a 120-degree angle. I think the easiest way to explain this is to show you. So we have, of course, our terminal side here, and 120 degrees would land here. So that is a 120-degree angle. What's going to be super, super important for us in this class is to deal with the reference angle. So the reference angle is the angle formed by the terminal side. So this is our terminal side, and the x-axis, and they make an acute angle. So here's our x-axis. We have an acute angle. So this angle right in here is our reference angle. Now, how many degrees is that? It's very simple. It's 180 minus 120. Those angles are supplementary. So that is a 60-degree reference angle. Now, something to think about. Reference angles are always positive, even if they're formed from a negative angle like B. So if you think about negative 135 degrees, we are going to go from here this way, negative 135 degrees. But the reference angle is going to be terminal side, x-axis, making an acute angle. This angle right here is the reference angle, and it will be positive. So we're going to do 180 minus 135. That means that this angle right here is a 45-degree reference angle. Okay, even though it was formed from an angle that went clockwise and had a negative degree measure, the reference angle is always positive, and it is always acute, and it is always formed with the x-axis. Some more examples. Negative 211. So I hope you're thinking, okay, that's more than 180. It's in the negative direction, so we're going clockwise. So it's going to land in quadrant 3, negative 211. And what we're going to do is we're going to say, well, our reference angle is here, terminal side, x-axis. So this is our reference angle. And what we're going to do is we're going to take away all of this. So forget that it's negative and just say 211 minus 180 gives us a 31-degree reference angle. Okay. The next example, a little complicated because we have 495 degrees. So we first have to think about what that would look like. So in my mind, I'm saying, okay, 495 minus 360 gives me a 135 degree angle. That's coterminal. Let's draw it. So we do have to do a full rotation. It's 360 and then 135, which would bring us here. Here's our terminal side. Here's our x-axis. Here's our reference angle. Now, that 135 is important because we're just going to say 180 minus 135 tells us that, again, we have a 45-degree reference angle. So I want you to notice that example B and example D both have 45-degree reference angles. One happens to be above the x-axis, one happens to be in quadrant 3 below the x-axis, but they're both 45-degree reference angles. Okay, 4 more examples. So 742. I'm going to try to think, okay, I'm not going to take away 360, I'm going to take away 720 degrees, which leaves me with a coterminal angle of 22 degrees. I'm going to keep that in mind when I draw this. It is a positive angle, so it's going counterclockwise. So here's my initial side. We're going to go 2 full rotations around and then 22 degrees past a full rotation, which lands us, right here. And now if we look, the reference angle, here's our terminal side, here's our x-axis making an acute angle right here. So this is a 22-degree reference angle. When it's in quadrant 1, when the terminal side lands in quadrant 1, there's not much calculation you have to do. This would be the reference angle. Okay, see if you can draw a negative 900-degree angle. This one's kind of a trick. Not really a trick, but it's a special case. So where would that land? So I hope you're thinking, okay, it's a negative angle, so I have to add rotations to figure out where this would land. If you add 360, you're not going to be positive. If you add 720, you're not going to be positive. But if you add 1080, you will be positive, and you will get a 180-degree angle. So that kind of lets you know where you're going to land. Initial side, 2 rotations, negative 360, negative 720, and negative 180. So an angle that lands on the x-axis has no reference angle. Okay, so there is no reference angle. Maybe you say there's a 0-degree reference angle, but usually we say there's no reference angle. Okay, the same would happen if we landed at like 90 degrees or 270 degrees. Okay, 2 more and then we're done. So on G, I'm asking you for the reference angle for a 1073-degree angle. So again, we're going to think about how many rotations we would need to draw this. So 2 full rotations and then 353 degrees after that. Okay, and again, what I did in calculations, I subtracted 720 degrees. So it tells me 2 full rotations. When I subtracted 720 degrees, I was left with 353 degrees. So that tells me where to sketch this. So initial side right here. 1, 2, And then 353 degrees brings us almost back for another full rotation. So here's my terminal side. Here's the acute angle formed by the x-axis. Here is my reference angle. So remember that was 353 degrees. So I'm just going to say 360 minus 353. And that tells me that that reference angle right there in green is 7 degrees. Okay, one more. Negative 99 degrees. So first we have to draw negative 99 degrees. Here's our terminal side. I hope you're thinking, well, that's a little bit more than 90. So here's negative 90. Negative 99 would be right about here. So that's negative 99. For the reference angle, we have our terminal side, which is right here, making an acute angle with the x-axis, which will be right here. This is our reference angle, and we're just going to say 180 minus 99, which gives us an 81 degree reference angle. So 81 degree reference angle. Okay, reference angles, super, super important. We're going to be working on the coordinate plane with reference angles for a very long time. So again, you have to remember, terminal side makes an acute angle with the x-axis, and it's always positive. I'm going to leave you to this part. Try on your own. We can figure that out in class if you're having trouble, but please, your directions are on here. Go ahead and use your calculator and see if you can convert to degrees, minutes, and seconds. Have a wonderful day, everybody.